Okay, we'll start the problem now. Okay, there's a, so initially, what is the length of the spring? Okay, let's have that one. Natural length L is telling in series. So I'll, initially it's at natural length. I'll switch on the cell, then charge will get deposited on the, so initially you can say switch is open here, or the cell is switched off. The natural length of the spring is L. So let's have one small diagram. So this will be, okay, this is the P, this is S, this is Q, this is a plate. So this length is what equal to D. And this length is what? Equal to L. So initially, so we'll bring one switch like, so there's no elongation. Spring is at natural length. No deflection. Put X equal to 0. Spring is at natural length. Now the same problem. So here, I'll close the switch. What will happen to the spring? So first a charge will come and deposit here. So let's assume that a charge will come and deposit. It will induce a charge minus Q, plus Q, and here minus Q. This will be a flow of charge in the circuit. Got it, no? Because of this charge deposited on the plates, electrostatic attractive force will act. P and S are fixed here, so they can't move. Whereas Q and R are movable. So what will be the position of the plate as the plates are going to shift here? The plates are going to the shift. So here come like this. So let's assume that these plates are going to shift. I show like this. So now what was the natural length? That L will be there like that only, no? I didn't disturb you, see that one. So the spring got elongated, so call that is R. And what is the separation? So separation, let it be equal to E. Just a diagram. So once you get the diagram, no, it'll be much easier. This you put it. So what is the now electrostatic force will act here. I'll show that Q also. Charge Q minus Q. Q and this will be minus Q. There is a plate S. No, any electrostatic force, the spring got elongated, no? So in what direction the spring force will be? Total elongation the spring, let it be X. Then what is X equal to? 2R. So the data given, let me analyze here. So total elongation of the spring is equal to 2R. And he has given if the extension in the spring in equilibrium is equal to separation between the plates. What is the separation between the plates? A, we assumed it A. So this X is equal to A. This is given. So therefore this A is equal to 2R. I think over once if can make up this much. So here what actually happens here? There is a spring force will be acting like this. Kx. Then the other side there will be electrostatic force. Similarly, on other plate also should act. I'm just showing only on the plate R and Q. The other plate will be fixed to rigidly something. Let's not bother on other plate. Other plate also force will be acting. Okay, let's come for some mathematics here. So what is D is equal to? Look at the diagram. D should be equal to L plus 2R plus 2E, and 2R should be equal to A, that one. So this will be L plus A plus 2E. So therefore this A is equal to D minus L by 3. Okay, this is the separation between the plates. So what is the capacitance of each plate will be now? C is equal to F naught A, you write it. Then what is the charge deposited? C into E by 2. Why E by 2? Because they are in series and they're having same capacitance. They're having same capacitance. Okay, fine. So what do you mean by C? Capacitance of capacitors. So this will substitute here. Q is equal to F naught 2A into E. Okay, this is about the charge. So what is value of A further? F naught A E 2 D minus L by 3. So 3 F naught okay, this is the expression for the charge. Okay, now at equilibrium. So it is saying equilibrium is telling. So let me use that word equilibrium. At equilibrium, so the electrostatic attractive force between the plates should balance the spring force. So here the Fe should be equal to the initial mathematics. Now at equilibrium, Fe should be equal to Kx. So what is Fe should be equal to? Q square by 2A epsilon naught. K equal to this X is equal to A, no? We got it here. So substituting this value of Q, solving for K will get the required answer. We have to substitute the value of Q here in this equation. So call this equation so solving this, I'll write down later on you check the calculation. Let me go for next problem. F naught A E square by I think the diagram is very important. If you can get this diagram, it's over. So it's all about the diagram. You should manage through the diagram. This particular question is all about the diagram. Here, spring, what is this? This is spring force, this is electrostatic force. What is Fe? This is force of attraction between the plates, and this is spring force. Till now, they didn't ask any question on this with the capacitor. So possibility of asking, because again, the capacitor spring both are same. Capacitor will store electrostatic energy, the spring will store mechanical energy. Both are same. Both are equivalent here. That's why we are just bringing that one. Later on, some as we go for in the revision, no. So there I'll bring some numericals where like a electrostatic energy, electrostatic potential energy. This is the elastic potential energy. So the principle behind them will be same. So where all that K is there, no, you can replace with equivalent capacitor terms. Some numericals are there, so which are not there for advanced, but in Olympiad can be asked. So there in the revision I'll discuss now. Now they may not be important.